As we talked earlier, the CNS is responsible for making decisions. Not only making decisions, but also analyzing the information, whereas the BNS would carry these information and decisions between the CNS and other organs in the body. This information is carried within nerves, which are the axons of many neurons bundled together. So now we have the nerves, and these nerves are axons of many neurons. So this is one neuron, another neuron, 3 neurons, 4 neurons, hundreds of neurons. Each one has its own axon. So these axons are bundled together within a nerve. So this is the nerve. And these are carrying information to and from the CNS. Now, depending on the origin of these nerves, we have either cranial nerves or spinal nerves. Cranial nerves are coming or originated and connected directly to the brain, whereas from their name, spinal nerves are originated and connected directly to the spinal cord. We have 12 pairs of cranial nerves and 31 pairs of spinal nerves. This is the video about them. Please watch it. Now, we can classify these nerves by their type. So over there in the previous slide, we saw them bear their origination or bear their origin. Now we can look at them by the type of information they carry. Okay, so here we have sensory neurons or sensory nerves, and these are, as you can guess, they are carrying sensory information. They are carrying sensory information, and usually these information, the sensory information, most of the time are going to the CNS, to either to the brain or spinal cord. Okay, so the sensory nerves are carrying sensory information, and these information are running or going toward the CNS. So these sensory nerves are collecting sensory information, collect information from somatic organs like skeletal muscles, or from autonomic organs, like stomach. Okay, so somatic like skeletal muscles, autonomic like the stomach. They are collecting this information and sending them to the CNS. Now think of somatic are the organs that we have control over, like voluntary organs. Think of autonomic as involuntary organs that we don't have control over it, like the liver, like the spleen, the stomach, and so on. So these nerves will carry this information in forms of action potentials. And again, as we said, they will be transmitted to the CNS. Now, for the somatic division, and as we understood, or we said in general, these are the organs under voluntary control, like skeletal muscles. However, their control sometimes is overridden by the CNS and becomes involuntary, like reflexes. Think, for example, when you touch something hot and you withdraw your hand immediately, and after you withdraw your hand, you realize that you touched that hot surface. This is the reflex. So reflexes are involuntary actions happening through the somatic division because it involves the skeletal muscles. There are different types of reflexes. We are going to talk about the spinal reflexes mainly. These are involuntary responses mediated primarily by the spinal cord and spinal nerves. So the decision of the reflex is happening or originated at the spinal cord with little or sometimes no brain involvement. So the spinal cord will take care of the decision, will analyze the data and take care of the decision. We have several types. We have the flexors cross-extensor reflex, and we have the stretch reflex. And the stretch reflex is like important in maintaining upright posture and movement. We will talk about them. This is an example of the flexor and the cross-extensor reflex. Flexor will cause you to lift your leg when you step on something sharp. And the cross-link extensor would make you shift your weight to the other leg to maintain balance. Both reflexes are happening in the spinal cord without involvement of the brain. So the brain will get notified about what happened, but the decision was already made. So the flexor reflex will cause you to withdraw your leg when you touch or when you step on something sharp, and immediately you will shift your weight to the other leg so you won't fall down. Okay? This is a video about the reflexes. Also, please watch it. Now, let's see now the atomic division. The atomic division. The atomic division, this is just to put it in a concept or to put it in a map. I will go back to several slides all the way to the beginning, just to remind you where we are. Maybe it's better like this. So now we are talking about the motor output. We talked about the somatic division, the control of skeletal muscles, and we said these are usually volunteer, but with reflexes they are involunteer. The other division of the motor output is the atomic division. This controls the smooth muscles, cardiac muscles, and the gland. And that's what we are going to study now. Let's go back to here. So for the atomic division, it controls the atomic body functions, the functions that we don't have control over. So these are no control, no conscious control over. These are many internal organs. And this division consists of two subdivisions, sympathetic and the parasympathetic. Both sympathetic motor neurons and sympathetic motor neurons innervate each organs. So both divisions are targeting the same organ or organs. We are talking, for example, about the stomach, the liver, the heart, and so on. So every one of these organs receives innervation or receive nerves from the sympathetic division and the parasympathetic division. However, they would act in opposite to each other. One would activate, the other one would inhibit, and so on. So they are working against each other, and we will understand, slightly will understand why is that. Now, the sympathetic division, usually we can put it in a general statement. It's a fight or flight situation. This is for the body movement and using energy. So it prepares the body for emergencies. It prepares the body for emergencies, for movement and using energy. Here, it will increase the heart rate and respiration. It will raise the blood pressure. It will dilate pupil. It will slow digestion and urine production. So here, it will make a lot of oxygen, a lot of blood, raise blood pressure to sustain that levels of oxygen in the blood, dilates pupils so we can see clearly, and slow digestion and urine production, so no waste of energy on minor functions during emergencies. And generally, it produced a unified response in all organs at once. How we oppose it or how we stop it? By the parasympathetic division. The parasympathetic division, in general, it conserves energy. It conserves energy. It is for resting and digesting. So this is over there, it was fight or flight. This is rest and digest. Okay, so here it relaxes the body, it boosts sympathetic division, and for example, it will lower the heart rate, respiration, it will increases digestion, permits defecation and urination. So it prepares the body. Think, for example, when you are sleeping, you want to go to sleep, your parasympathetic division is dominating your body. And acetylcholine is a key neurotransmitters in this case. Now again, both systems are working at the same time and working antagonistically. So they are working against each other to maintain the homeostasis. These are the effects of the sympathetic and the parasympathetic on the same organs. So please go through this image and go through this table to see some differences between the parasympathetic and the sympathetic, also between the somatic and the autonomic divisions in terms of neurotransmitters and the numbers of neurons. This is just for your information, and I don't think I'm going to ask you about it. This is a video also about the autonomic nervous system. Okay, I will stop here and I will start a new video where we are going to talk about brain and spinal cord, mainly protection and other structure, other features of them.